Hi, welcome back to the channel. So in this video, we will see the continuation part of op-amp. That is, we will see the op-amp. First, we will see the golden rules. We will see the golden rules as well as the op-amp applications or the configurations. Right. So what is the meaning of golden rules here? So there are two rules. One rule is with respect to current, and other rule is with respect to voltage is there. So if you understand those two rules, you can do any type of configurations of the op-amp like inverting amplifier, non-inverting amplifier, summing amplifiers, integrators, differentiators. All these applications are going to work out if I know these golden rules. So first I will call first golden rule is associated with the current, right? So here I will draw a op-amp symbol which is having 5 terminals, minus, plus V, minus V, it is output, it is some two inputs, V1 and V2, right? So here I will write the current with respect to here the first V1 and one more the current I2 here like this. So what is the golden rule is, there is no current which is going to be drawn with respect to this terminal and this terminal. So no current will be from inverting as well as a non-inverting terminal, right? So we can call that as I1 and I2 values as 0. That is the first rule. Then second rule, we will take with respect to voltage. So here there is a concept of virtual ground. That is virtual ground concept, we will call that. Suppose I will take the same op-amp like this, right? So plus V minus V, it is a 741 op-amp, same. So it is V1 and it is V2. So assume that this V2 I will be having like this ground connection. So from the concept of virtual ground, if any one of the input is grounded, if any one of the input is grounded, we should consider the another input is also at the same ground potential, so that we should call V1 and V2 is equals to 0, or sometimes we will write this as V1 and V are equal. Both the inputs are equal. Sometimes we call it as from the concept of virtual ground. So even though there is no physical connection, between these two, we should consider the voltages as 0. So that is the concept of current as well as voltage with respect to the golden rules of op-amp. If I know these two concepts, then we can derive any type of derivations, right? So first we will derive the inverting amplifier with the help of these, right? So currents drawn by the op-amp is 0, as well as the voltage is from the virtual ground concept. We can treat if any one of the input is grounded, other one also we should consider as at the ground potential, or both the input voltages are equal, right? So this is the first thing we should do in case of the op-amp considerations, right? So now we will see the op-amp applications, or we can call it as the op-amp configurations, right? So we will write it as op-amp configurations or the op-amp applications. How the op-amp can be used as? So first one, op-amp can be used as inverting amplifier. What it is? Inverting amplifier. So we should draw the circuit diagram how the inverting amplifier look like. So take the op-amp, right? Here I will be having 5 terminals. So for this terminal, I will take one resistance and I will connect. So here we will consider a feedback resistance and we will connect it, right? So here I will call this as something point A, and this point I will call as point B, right? So this one I will call it as something like R, this as RF feedback resistance. This is output, this is plus V and this is minus V. This is minus and this is plus. This is 741 op-amp, right? So I will call this as V1 and I will call this as V2. So we have used the same op-amp symbol with 5 terminals, but for the first terminal we are considering V1 is input. V1 is input which is connected to which terminal? Negative terminal, right? So it is connected to negative terminal, hence it is called as inverting. What is the job of this amplifier is, whatever the input you will give at the input side, it is going to invert at the output side, right? So that is the meaning of this, right? It is exactly behaving like in the digital circuits, it is behaving like what type of gate? Not a gate. It may be the MCQ question. Inverting amplifier acts as what type of gate? Not gate. If you are giving 0 here, it will give 1. If we are giving 1 here, it will give 0. So that is the operation of not gate, right? Same thing here. But it is an analog case. So what it is going to give you is, if you are giving the input like this, my input is like this, and your output is going to be like this. What is happening here? Phase shift is happening. What is the phase shift? How we are going to measure this phase shift? With help of degree. Here we will call it as 180-degree phase shift. That is, these two are out of phase. The angle between this and this is 180 degree, right? So here it is 0 degree, here it is 180 degree. So the difference is 180 degree. That is the meaning of out of phase. We will call it as out of phase. Both the input and outputs are not in phase. Those are out of phase. So we should prove this mathematically, right? For that, we will consider here the concept of same whatever we have considered earlier. So it is inverting terminal. Input is given at the inverting terminal. So here we know that from the concept of virtual ground, in this case what is happening? B is at ground potential, right? And we can consider A is also at the what type of potential? Ground potential. So we can write VA is equals to VB is equals to ground means 0. So this is my first equation. It came from what? Virtual ground concept, golden rule number 2. With the help of this, we have done this, right? Now, we will divide this circuit into 2 parts. What are those 2 parts? Input side as well as output side. First, I will write what is input side. Okay. So, here, this part is input side, right? So, here, in the input side, what are the elements I will be having? V1 I will be having, this A I will be having, voltage corresponding to this, I can write it as VA, right? So what is the current I should draw? So the resistance is here, voltage is here, through this the current will flow. What is that current? I will mention it as A. The current will move up to this point A. After this A, it is having 2 options. One, it has to move in this direction, other it has to move up, right? So whether the current will move in this direction? No, because golden rule number 1 saying there is no current is going to be drawn at this moment. So the other option is current should move through like this, the same current I. The current which is entering at this node is leaving is I, right? And it is going to reach at the last stage. So here input side. So now I should write, this is, I will call as a input side. What is the input side? This is the input side. So for the input side, I should write the current equation I. What is I? How I can write this? I is equals to, what is the relationship between I and V? We know that by the Ohm's law, I is equals to V by R. So I should write what is the current I flowing through this resistance can be as, which is V1. It is going from here V1 and minus what is this voltage at A? It is VA divided by what is the resistance I will be having? R. So this is my equation number. Before that, we'll see now. V1 minus VA divided by R. Now, what is the value of VA? VA value is 0. So, I can write this as V1 divided by R. So, this as equation number 2. Right? So, this is the equation number 2. We got from which side? Input side. So, now we should go for the output side. So, here, so go for the output side. How the output side is? Output side is this part. Right? So this part we should see. We should write this type of Ohm's law current equation. What is the current which is flowing through the resistance? What is the one more resistance which is present? Feedback resistance. So the current which is flowing through the feedback resistance I is equals to V by R. We should follow this format, V by R. But what is V? How I can write V? It is going from voltage A, that is VA, minus what is this end? Output, V output, divided by what is the resistance? RF. That you should write, right? But what is here VA? What is the value of VA? This is 0. If it is 0, what you will get? V naught by RF. How it is going to be 0? This is from the virtual ground concept. We have done that. It is 0, right? Then after that, what you will get? I is equals to minus V naught divided by RF. I will take this as equation number 3. Now, we should apply this. What we should apply? Kirchhoff current law. What is the Kirchhoff current law says? Sum of all the nodes is the current with respect to that is 0, or the current entering is equal to current leaving. Which is the current entering at the node A, I, which is the current which is leaving, I. So here we can call this equation number 2 is equals to equation number 3, because look at the LHS, both are same. One is at the input side entering, it is entering current, it is leaving current. Both are equal to same now, according to Kirchhoff current law at node A. So how I can write now? So equate the RHS. V1 divided by R is equals to minus V naught divided by RF, right? So this implies how I can write this with respect to V naught and V1. So I can take here V naught and V1 is equals to minus. So if I take here minus RF divided by R1. V naught by V1 is equals to minus RF by R1. So I can write this as V naught is equals to minus RF by R1 multiplied by V1, right? This is the output expression for an inverting amplifier. And also we can write A as output divided by input. In this case, V1 is the input. So is equals to what? Minus RF divided by R1. Gain can be represented as output divided by input. So what is the gain? Gain is RF divided by R1. So we have written two. One is output expression and other is gain, right? What is this minus sign indicates? It is telling you that the input and output waveforms are what? It is 180 degree out of phase. So whatever is given, that is going to be inverse, that is negation, because of input is given to the negative terminal. So how we can draw this? How we can draw this input and output now? So with the help of these equations at the end, we came to know that with the mathematical equations, here both are 180 degree phase shift. So I can draw here the input is like this. If the input is like this, so here the output can be drawn like here. I will make the lines like this. If it is plus, I will get minus. If it is minus, I will get plus. Same thing which follows, plus, minus, minus, plus, plus, minus. So these two are 180 degree out of phase. What are that? 180 degree out of phase. So this is the waveforms of inverting amplifier. So this minus is telling that it is 180 degree out of phase, right? Thank you. In the next videos, we'll see still more derivations with respect to op amp. So next one we'll consider is non-inverting amplifier. That we'll see in the next video. Thank you.